Welcome to the module on radiological and nuclear emergencies. By the end of this module, you will be able to define radiological and nuclear emergencies, describe radiation and its types, identify how radiation is used in different sectors, explain radiation exposure and its types, describe the impact of exposure to large doses of radiation on humans, explain the do's and don'ts in radiological and nuclear emergencies, and explain the role of volunteers in radiological and nuclear emergencies. Let us begin by understanding what are radiological emergencies. Radiological emergencies refer to unexpected and potentially hazardous situations involving the release, exposure or contamination of ionizing radiation. The radiations released can be of different types such as alpha particles, beta particles, neutrons, gamma rays and X-rays. Radiological emergencies can occur in various settings, including nuclear facilities, hospitals, industries, agriculture, and research institutions. Radiological emergencies may occur during the transportation of radioactive or nuclear materials. This can pose a risk to the safety and health of workers, the public, and the environment. It may necessitate immediate response and control measures to minimize their impact and prevent harm. Let us next learn about nuclear emergencies. A nuclear emergency could be declared if there is an accident or an intentional release of potentially harmful radioactive materials. The exposure to radiation from these radioactive materials can cause health risks. The memories of those devastating nuclear weapon attacks on Hiroshima and Nagasaki, and the way we all heard about the reactor accidents at 3 Mile Island in the USA and Chernobyl in the former USSR and Fukushima Daiichi nuclear power plant accident in Japan have really shaped how people think about any nuclear emergency. It is hard to forget those events. Many people tend to associate nuclear emergencies only with these historical events. However, it is essential to remember that we should also be ready for smaller-scale nuclear and radiological emergencies. Let us learn more about radiation and its impact. Radiation is energy in motion. The simplest and most well-known example of radiation is light, either from the sun or an object on fire. We all know that when the intensity of this light is higher, for example in summer, it has the potential to cause harm. When it is lower than a certain limit, it is soothing and harmless. But during winter, we use fire to heat ourselves using radiation emanating from it because the intensity of light or radiation from the sun becomes less. Therefore, radiation is similar to a drug that when taken in the right dose has more benefit than harm caused by it, whereas an overdose may even cause death. Radiation can be either ionizing or non-ionizing in nature. Click each type to learn more. Ionizing radiation is the radiation that has sufficient energy to eject electrons from atoms, that is, to ionize atoms, such as alpha particles, beta particles, neutrons, gamma rays and X-rays. Non-ionizing radiation is the kind of radiation that does not have sufficient energy to remove an electron from an atom. For example, radiation from power lines, radio and TV waves, cell phones, microwaves, infrared devices, visible light and so on. Radiation is used in different sectors. For example, In healthcare, radiation is used for diagnosis and treatment. Radiation is used in the industrial sector for food processing, radiography, gauges and measurement. In the field of research, radiation is used for finding irradiating samples, calibration sources and tracers. Additionally, in agriculture sector, radiation is used for tracer studies. Next, let us learn about modes of exposure to radiation. We are practically in a sea of radiation that reach us from either outer space or from the materials on Earth. This is known as background radiation. Background radiation refers to the continuous exposure of individuals to low levels of ionizing radiation originating from natural sources in the environment, including cosmic rays from outer space, terrestrial gamma rays from the Earth's materials, and the presence of naturally occurring radioactive materials in soil, building materials and other surroundings. This ambient radiation is a part of everyday life, and the typical annual exposure to natural background radiation is about 2.4 millisieverts per year. It is important to note that background radiation is relatively low and forms a baseline level of radiation that individuals encounter regularly. Radiation exposure refers to the situation where the body is exposed to radiation. There are two types of radiation exposure, namely internal exposure and external exposure. External exposure means to receive radiation that comes from radioactive materials existing on the ground or in the air, or attached to clothes or the surface of the body. Conversely, internal exposure is caused when a person has a meal and takes in radioactive materials in the food or drink, when a person breathes in radioactive materials in the air, when radioactive materials are absorbed through the skin, when radioactive materials enter the body from a wound, when radiopharmaceuticals containing radioactive materials are administered for the purpose of medical treatment. The body is equally exposed to radiation in both cases. Next, let us learn about exposure to large doses of radiation. When dealing with high levels of radiation, it is crucial to understand the potential risks it poses. Exposure to large doses of radiation can lead to two distinct types of biological effects, that is, somatic effect and genetic effect. Somatic effect directly affects the person exposed. Genetic effect can impact the descendants of the exposed individuals. Let us look at the annual average values of the effective dose from natural sources of radiation. These values represent the amount of radiation exposure we receive from elements like cosmic rays, terrestrial gamma rays, internal radiation, and radon along with its decay products. In the UK, the typical annual effective dose from these natural sources adds up to around 2.4 millisieverts per year. Next, let us learn about the impact of radiological and nuclear incidents in today's time. Today, the impact of radiological and nuclear incidents could be even more significant than in the past. That's because our population has grown, and we have more advanced urban infrastructure due to economic progress. However, having better infrastructure can actually help us during these emergencies. It improves communication, transportation, and medical support, making us better prepared. Next, let us learn about preparedness for nuclear and radiological emergencies. The handling of nuclear emergencies requires coordination among different service groups of the nuclear facility. In the event of potential radiological consequences in the public domain, all the authorities at the three levels, that is, district, state and central, will play a vital role and assist the off-site officials in effectively responding to and keeping the public informed on the precautions to be taken. Next, let us learn about some of these precautions. During a radiological and nuclear emergency, you should go indoors and stay inside. Close doors, windows to prevent exposure to radiation. Cover all food, water and consume only such covered items. Switch on the radio or television and look out for public announcements from your local authority. In the open area, cover your face and body with a wet handkerchief, towel, dhoti or sari. Return home, change or remove clothes. Have a complete wash and use fresh clothing. Extend full cooperation to local authorities and obey their instructions completely, be it for taking medication, evacuation, etc. You must be aware of nuclear radiation hazard. Discuss about nuclear radiation safety among children and family members to reduce their fear of radiation. Do not panic, do not believe in rumors passed on by word of mouth from one person to another. Do not stay or go outside to prevent exposure to radiation. As far as possible, avoid water from open wells, ponds, exposed crops and vegetables, food, water or milk from outside. Do not disobey any instruction of the district or civil defense authorities who would be doing their best to ensure the safety of you, your family and your property. Let us look at the initiatives of Department of Atomic Energy. The Department of Atomic Energy and its constituent establishments play a pivotal role in advancing nuclear science, technology, and innovation. DAE is responsible for the entire spectrum of activities related to nuclear science and technology encompassing power generation, research, development, safety, security, safeguards, environmental protection, international collaborations and societal applications. DAE works towards harnessing radiation as a tool for problem solving on various fronts like agriculture, healthcare and industrial applications. To improve the public perception of safe use of atomic energy and radiation for peaceful and beneficial purposes, it is necessary to convey the right information to public. Department of Atomic Energy already has such an active program both in print and electronic media. Now, let us further learn about the role of Atomic Energy Regulatory Board. To create awareness of the Atomic Energy Regulatory Board's role towards safety in using nuclear and radiation applications safely in this country, it has decided to carry out a public awareness program and also organize and participate in such programs organized by others. It has also decided to make a knowledge base available on its website for visitors seeking information on how safe use of atomic energy and radiation is ensured without harming human beings and the environment. Next, let us learn about the role of volunteer during radiological and nuclear emergency situations. The NDRF's role in nuclear radiological emergencies is pivotal, starting with intensive capacity building for first responders, equipping them with specialized skills. It prioritizes community awareness, ensuring civilians are informed and prepared. Conducting joint mock exercises enhances coordination among stakeholders for a more effective response. When off-site emergencies demand immediate action, the NDRF assists in the orderly evacuation of the public, ensuring safety. Their expertise extends to post-incident measures, conducting vital decontamination of affected individuals and areas to contain radiation. In unforeseen situations, collaboration with experts from DAE and DRDO enables swift and comprehensive responses, pooling resources and expertise. This collective effort underscores the NDRF's critical role in mitigating the impact of nuclear and radiological emergencies for public safety. Volunteers can help in many ways during radiological and nuclear emergencies. Volunteers can help in dissemination of warning to people. They can help in evacuation of people to safer places. Volunteers can cooperate with authorities for correct procedures and safety of victims. Volunteers need to be very cautious and notice any unusual and doubtful things or activity. Further, bring it to the notice of authorities. Volunteers can spread awareness in the community about exposure through contaminated food, land or water, proximity to airborne transmission. With this, we have come to the end of the module. Let's recollect the key points discussed in the module. Radiological emergencies can occur at nuclear facilities during the use of radiation sources, accidents involving radioactive materials, and malevolent activities involving radiation sources. Background radiation refers to the continuous exposure of individuals to low levels of ionizing radiation originating from natural sources in the environment. Radiation exposure refers to the situation where the body is exposed to radiation. Exposure to large doses of radiation can have somatic and genetic effects. Annual exposure to natural background radiation is about 2.4 millisieverts per year. Preparedness for nuclear and radiological emergencies involves coordination among various service groups and authorities at district, state and central levels. Education on nuclear radiation safety is encouraged to reduce fear and improve preparedness among families and children. Now, it is time to check your understanding of the topic. This is an evaluation exercise. All questions are equally weighted. You need to score at least 60% to pass the test. Read the questions carefully and select the appropriate options. Congratulations!